In this video, we would discuss an algorithm in solving the linear congruence wherein a and m are not relatively prime. Just like in our example here that 10 is our a, m is 52, and their GCD is not 1, and so they are not relatively prime. But if they are relatively prime, we have a separate video that discusses the method in solving that linear congruence. Just click that I icon there for that suggested video. Observe that by definition, this congruence would imply us that 52 divides 10x minus 18. If you want to know more about congruence, we have that suggested video. In that suggested video, definition of divisibility is also being discussed. That is, if we have 52 divides 10x minus 18, it means that there exists an integer y such that 10x minus 18 is equal to 52 times y. Now this equation is the same thing as this. And observe that this equation is actually a linear Diophantine equation. If you want to know more about linear Diophantine equation, we have a separate video that discusses this. In that video about linear Diophantine equation, it's being discussed that if the numerical coefficients of our x and y, in this case 10 and negative 52, would divide the constant at the right side, and that is the 18 here, definitely there will be a solution to this equation. And yes, the GCD or the greatest common divisor of our 10 and negative 52 here would actually be 2, and 2 divides 18. Thus, we really have a solution for this linear Diophantine equation. Also, observe that 2 divides 10, negative 52, and 18, and so we can actually simplify this equation and have this. Aside from that, observe that we can convert this into modular arithmetic. That is, we now have 5x is congruent to 9 modulo 26. Since 10x congruent to 18 modulo 52 is the same thing as 5x congruent to 9 modulo 26, we can just solve for the linear congruence and said 5x congruent to 9 modulo 26. A method in solving linear congruence with the use of an inverse A modulo m suggests that we can do this considering that 5 and 26 are relatively prime or their GCD is equal to 1. Hence, solving 10x congruent to 18 modulo 52 is the same thing as us solving 5x congruent to 9 modulo 26. We have a thorough discussion on how to solve this linear congruence in a separate video. Feel free to watch that video if you feel like you're confused on how to do this. In that suggested video, step 1 would be for us to get the equivalence class of 1 with respect to modulo 26. Next would be for us to choose a member of the set that is divisible by a, and our a here is 5, and our first member that is divisible by 5 would be 105. After this, we have to get a multiplier for 10x and 18, and that multiplier would be the quotient when we divide 105 by 5. Generally, that would be the first member in the equivalence class of 1 divided by our a. So yes, we have a thorough discussion again for this method, so if you feel like you're really confused at this time, it's preferable to watch that first. After solving this linear congruence, we now have our simplified answer, and that would be x is congruent to 7 modulo 26. Observe that in verifying this answer, we can definitely use either the congruence 10x congruent to 18 modulo 52 or that 5x congruent to 9 modulo 26. Let's see if you got the gist. Try to solve this linear congruence.